All right, this is going to be the cable clip video. And in this one, we're going to be using the sheet metal application to make this cable clip. So in NX, we're going to go to File, New, open up a new file. And we're going to be doing a model. Now we could start with a model file. We can also start with a sheet metal file. You can get to the sheet metal application even if you start a regular model. We are going to be in millimeters. So make sure you change your units to millimeters. I'm going to start in the sheet metal application. Make sure you're saving this to a folder you can locate. And we're just going to name this cable clip. And we can say OK. Now with the sheet metal application, you'll see that there's a ton of different tools that are now available to us that weren't there before. If you are in just a regular model, if you go to the application tab, you can go to sheet metal right here. You can actually go back and forth between modeling and sheet metal. But if you're in just regular model and you want to use the sheet metal application, just go to application, sheet metal. Now the tools that we're going to be using for the cable clip mainly is the tab and the flange, and then a couple other things over here that we'll get into. The tab and the flange, so the tab is like the starting point, and then the flange is how we're going to be adding the bends. So we're about to start a tab, and the tab that we're going to start off with is this 44 by 96 area here. Now this area does encompass this bend, so we've got this vertical bend here, but that bend is located inside this 44 by 96 area. So we're going to use that to our advantage here in a second when we actually make that bend. But we are going to start off with our main tab. So with NX open, we can go to tab. And you'll notice with the tab that the thickness is already in place, right? So I can't change this value at all. We have to change this someplace else. The reason for this is that, when we add a bend, okay, we're changing the size of the material. The amount of material that's added or subtracted is based off of the material thickness. There's more that goes into it, but the thickness here plays a part in other things. So this, and NX uses this to factor what those values are. So to change this thickness, and we do need to change it because 3 millimeters is the default. But if you look at our drawing, the drawing is asking for 10 millimeters, okay? So what we'll do is if we go to File, right over to the right, you have Preferences. We're going to go to Sheet Metal. So that's File, Preferences, Sheet Metal. And here we have the global parameters for material thickness, bend radius, and then our relief depth and width. We're going to change this to 10 millimeters for all of these values. So 10 millimeters for all four. We can say OK. Now when we go to tab, we'll see 10 millimeter thickness. Now let's say that we forgot about that and we continued to design our part. We could then go to File, Preferences, Sheet Metal, and change it to 10 millimeters, and it could still, everything would update. So all the values that we put in for like lengths and widths and everything would still be there. It's just that the thickness would be 10 millimeters instead of 3. That would change things whenever we go to make our flat pattern. So the size of the cutout would be different, but the parameters that we put in place would still be there. So it's not the end of the world if we forget, but it's better to have it in before than later. So with the tab, what it's looking for is essentially a 2D boundary to create the tab of, which we don't have yet. So when we select curve, we're going to go to Sketch section. We'll sketch on the top plane. Say OK. We're going to make a rectangle here. starting at the origin. And this is going to be our 44 by 96 rectangle. So say 44 by 96. And I'll say finish. We'll say okay. Now there is our base tab. Now 44 by 96, that's what we're looking at right here. So part of that 44 by 96 area is this bend. That is going to be our first flange. So the first flange is, the width of it is this full 44 millimeters. The height is 52 millimeters, but the height of the bend here starts from the bottom. So the 52 millimeters, that dimension is specifying the distance from the bottom of the bend to the top. So maybe this clip needs to fit in somewhere in the space. The overall space that we have is 52 millimeters, or I guess would be larger than that for this to fit in. But we have specified that distance. It's going to come important here in a minute. So let's see how we're going to add that in. We're going to go to a flange, and flange is asking for an edge. It's asking for an edge. We're going to select the edge where we want the bend to be, and this is essentially going to bend. So if I selected this edge, it would bend up. If I selected this edge, it would bend down. So we're going to select this edge, and it's going to bend up. Now, there's some other options here. So as far as the width options, full means that the full edge, so the whole edge will be bent. Let's say that we just wanted to bend the center. We could say at center, and we could specify a distance for the center. There's some others. We'll use at end here for our second one, but for this one, it is specified that we have a full 44 millimeter bend. Now the next option is our length. The length is the length of the bend, but if we look down at the length reference, so here's the length is our value, but the length reference changes sort of what this is referencing. So if I come to the side, and I'll change this back to 52. So 52 millimeters as far as our length, but if I change my length reference to inside, hopefully you can see that now that's technically longer than it was before, because we're changing where our start reference is at. So the length reference changes where this value starts from. So right now it's inside, meaning that the value starts essentially on the inside of this material. If I change this to outside, now that 52 is starting from the outside of the material. Now we have been told that it's 52 millimeters from the outside to the top. So outside is what we want for this. The next option that we have is inset. So inset is going to be sort of the other side of the bend. So if we look at this sort of wireframe rectangle, this is the tab, part of the tab that we made just a minute ago. Look at where the bend is occurring. So the bend is happening inside of that tab. That's because we have material inside selected. If I were to change this to material outside, notice the bend has changed to where the bend is now ending, where this material is on the other side of that tab. So the material is outside of that tab that we made. We could say bend outside, where the bend doesn't start until the end of the material. So here is where that tab ended, right? And then the bend begins. We want material inside. That's how we're able to get away with looking at it from the top view and still seeing just the 44 by 96 millimeter tab, is because the material is inside. So for this tab, we've got a full width option. Our length is 52 millimeters. Angle is still 90. Length reference is outside and our material is inside. We can say okay. And that is our first bend. Let's take a look at our second bend. Our second bend, the bend is 50 millimeters instead of the 52 that we have at the top. So it's 50 millimeters. And the bend is not going to start until the end of the part, or the outside of the part. Also, the bend here does not go to the full edge, right? This does not continue all the way over. So it starts at the end and it only goes 44 millimeters over. And it's 90 degrees and it goes 50 millimeters. So let's look at how we're going to make this one. So we'll go to another flange. So we'll use another flange. Now this was the bend up. This one's bending down. So I'm going to choose this edge. And this is not correct. That's because we have our width option to full. This is not a full bend. So we'll change this to at end. And it's asking for to specify a point. So it's saying, well, which end do you want to start at, right? And we want to start at this end. So we'll say start over here. The width, this will be the width of our flange. This is going to be 44 millimeters. The length is 50. So the length is the same as what we had before as far as what it's referencing, right? And if we look at our drawing, so we're referencing from this top to the bottom. So we want to make sure that we have the correct length reference. So if we move over, length reference inside is going to be changing to where we're referencing the bottom. If we do outside, we're referencing the top. So we still want outside for our length reference. And we said that we don't want the bend to start until it's outside of the material or outside of the tab. So if I selected material outside, the bend is still occurring inside that tab area, right? So you sort of see it like halfway through the bend, essentially. The material is lining up with the edge of our tab. That's not what we have. We want to where the bend doesn't even start until the edge of the tab. So if we change this to bend outside, now the bend is starting. So this is the start of the bend, is the edge of our tab. That's what we want. We want the bend to start outside of the tab. So that's going to be bend outside. So our width 44, length is 50. Length reference is outside, and our inset is bend outside. Now, before we hit OK, let's talk about our bend relief. So right now, yours probably looks something like this. This is a relief that's being cut into our tab to relieve the bend. Typically, this is what we want, and NX put this in by default, and that has to do with the parameters that we told it whenever we changed the values at the beginning. This part does not have a bend relief though. So to turn this off, we're going to go to relief and our flange settings here, relief, and we're going to change this to none. There's some other options that you can do, but we're going to say none. So we just have this flat area here just for this part. So now we can say okay. We're just about there. Let's add some other features. Let's round over these edges. Okay, these are just 22 millimeter rounds. This is a full round over these parts. So if we go to corner this area here, we have brake corner. We're going to change that radius to 22 millimeters. And we can start to select the curves that we want to add the round to. This is, or break the corner of. This is sort of like the edge blend in the modeling application. But here it's called brake corner. Now let's look at the holes. So we have 3 holes. 2 of them are centered along the arcs that we just created. On both of the flanges, and they're both 20 millimeters diameter. They're through holes. And then the other one that we have is a 22 millimeter diameter hole, and it is aligned with the 2 flanges centrally. So it's aligned horizontally and vertically with our flanges. Let's do the holes here first, and then we'll go to the 22 millimeter hole. So in NX, we still have the hole tool. It's going to be over here in the modeling environment, or the modeling area of our home tab. Under more, you'll see the hole tool. We'll go to that. Now this is going to be our 20 millimeter hole. So we'll say 20. Simple and custom is fine. We'll say 20 millimeters. And we are going to be picking up the center points of our flanges, not the edge, we want the center point. Through body. So there's our 2 20 millimeter diameter holes. And the last hole that we have is a 22 millimeter diameter hole. And then again, that is aligned with the flanges that we have. So we'll do another hole. This one is 22 millimeters. And we are going to go to sketch section to create the center point for this hole. This is going to be on this top surface of our part. I'll just place the point down kind of close where it needs to be. And we're going to use our constraints to align this with our 2 flanges. So we will turn on our persistent relations, and I'll use a make midpoint aligned. I'll select the point, and I'm going to select these 2 lines here. I need to change the scope first, so within work part only, I'll select that line. So it's going to align it with that midpoint. And I'll do the same thing again, this time with the line of our other flange. And I'll say OK. So now it's aligned with this midpoint and this midpoint. Sketch is fully defined. I'll hit finish. And there is our hole through body. And there is our cable clip. Now, the last thing that we want to do for this is we want to create a flat pattern and then export the flat pattern as a DXF file. So to create the flat pattern, we're going to come up here to flat pattern. It's going to ask us to select the upward face. So when we create the flat pattern, it unbends our bends and gives us a 2D shape that can then be cut out or stamped out or machined out some other way to create our shape that can then be bent and create our final product here. So our upward face is just going to be the tab, the top of the tab. I'll say OK, and it says that it was created. And you'll say, well, it's here, but where is it? So if you actually want to see the flat pattern, it is added as another model view. So if we go to model views in our part navigator, you'll see flat pattern number 1. If we double click on it, now we're in that view, and you can sort of see the information that is created. So a lot of this is helpful. a lot of this is not helpful for the actual DXF file. So depending on what you're doing, so let's just say that we are plasma cutting or laser cutting this out. The plasma cutter, or the laser cutter, is going to follow each individual line. So if we sent this over to actually get cut out, we'd be left with just a bunch of pieces, right? So this is helpful for some things, not others. But the way that we actually export what we want is underneath flat pattern, we have export flat pattern. Okay, so we'll go to that. And this is where we get to select what actually gets added to the DXF file that is then exported. So to get rid of those bin lines, so these bin lines that we don't really want for a DXF file that's going to be sent to be cut out on the plasma cutter, we don't want the bin lines, okay? So we're going to export this flat pattern. Again, change the location of where this is actually exported to so you can access it. And we'll all say okay. And I'm going to open that up. All right, here's that DXF file that we just exported. Notice that the bin lines are not there. We just have our holes and the lines for the perimeter. So something like this it would be good to send to get plasma cut or laser cut, just the lines that we want to actually cut.